Hi and welcome to the next section of OSPF. In this section we'll talk about the multi-area OSPF. We'll talk about the single area OSPF disadvantages. We'll talk about the router types in OSPF multi-area, and we'll talk about OSPF LSAs and multi-area OSPF area types. So let's say that we're running our single area OSPF and we had 5 routers, but now we expanded our network to 15 routers. By adding more routers, we'll have a consequence, which is the growth of the link state database, which will start to consume more and more resources, CPU and RAM. At this point, the OSPF will become power hungry, and it will require more and more resource-capable devices, which will drive the cost up. You'll have to buy more expensive routers. So, OSPF multi-area was introduced. This will create multiple areas, which will reduce the size of the link state database by using regular areas or special area types, and each area can have its own purpose and its own functionality. Also, it is important to mention that area 0 is the backbone area, or you can say that area 0 is the core area, and the routers in area 0 should have the more powerful devices configured inside it, because routers in area 0 will receive LSAs from any other areas. All areas should be directly connected to area 0, but let's say that you have this area 3 here, which is directly connected to area 2. We can create a virtual link which will connect area 0 and area 3, thus making this topology to work. In OSPF multi-area, the routers can have multiple purposes. The routers which are inside an area are called internal routers. The routers which are at the edge of an area and have an external connection is called the autonomous system boundary router, and it's basically a router that connects the OSPF domain with external world. We can have backbone routers, which are all the routers which have at least one link in area 0, and we can have area border routers, which are the routers with links in 2 or more areas, interconnecting other areas to area 0 or the backbone area, meaning that we cannot have ABRs or area border routers with links that are not in area 0 and any other area. And a router can be in multiple areas at the same time, and the areas are calculated mostly for the interfaces, not for the whole router itself. If you can see this, for the router R7, only this interface is in the area 1, and the rest of interfaces are in the area 0. Link state advertisements are used to transfer routing updates between the routers, and we can have several types of link state advertisements, and they are defined in order to optimize the route sharing process. We can have the type 1 LSA, which is describing the router links, and this LSA is describing the interfaces belonging to one router, and type 1 LSA is being sent to the routers which have interfaces in the same area. So area 0 will have its own type 1 LSAs, and area 1 will have its own type 1 LSAs. We can also have type 2 LSAs, which are describing network links. And this LSA is used in multi-access networks, and type 2 LSAs will originate from the designated router, and it will describe all the routers attached to the network, and the updates are being sent intra-area. Also note that type 2 LSA are used only in area 0. Link state advertisements are used to transfer routing updates between the routers and describe the routes learned from router links and network links. Type 3 LSAs are sent by area board router. From the area, these LSAs are originating to other areas, so updates are sent inter-area. So R2 will send the type 3 LSAs with the routes learned from the area 1, and also router 2 will send type 3 LSAs into area 1 with the routes which he learned from area 0. We also can have the autonomous system boundary router summary LSA or type 4 LSA, which is used to share the router ID of the ASBRs located in other areas. And these LSAs are sent by the ABR located in the area where the ASBR is located to other OSPF areas. So again, if R3 is an ASBR, R2 will send a type 4 LSA and it will inform other routers that ASBR is located in area 1. Also, type 4-5 LSAs, it shares routers learned from other routing protocols, and these type 5 LSAs are describing external routes, and they are shared by ASBRs. Type 5 LSAs are being sent in every area except the stub areas. You will see what this means in other slides. We also can have type 7 LSAs, which is not so stubby area external routes, and it is similar to external LSAs, but the ASBR is a router in the not so stubby area. It will create its own type 7 LSA, which is similar to type 5 LSA, and first the type 7 LSA will be created by SBR in NSSA. It will send to the ABR, and ABR will translate this type 7 LSAs into type 5 LSAs, and it will announce the external routes, the type 5 LSA. Okay, so let's check some regular areas in OSPF. We'll have area 0 and area 1, and we'll have the R2 as the ABR and R3 as an ASBR. So first of all, the routes will share between them the type 1 LSA. The router R2 will inform area 0 routers, the routes which it learned from area 1, and it will inform routes from the area 1, the routes which were learned from area 0. It will also, R2 will also send a type 4 LSA, and it will inform other routers that ASBR is located in area 1. Since this is a regular area, the ASBR will send a type 5 LSA, and it will share the external routes. The type 5 LSA is passed to the ABR, and ABR is passing the type 5 LSA to other routers in the area. Okay, so the first area type is the regular area type, and we can see all the messages which are being exchanged. But we can also have the stub area. The stub area is an area that doesn't contain ASBR, and it will accept only type 3 LSAs, meaning that it will accept only the routes learned from other areas. If let's say that we'll have here an ASBR and it will share some external routes, the stub area will not accept the external routes and it will only accept the type 3 LSA. Let's see how do you configure the stub area on R2 and on R3. You will configure the interface on both devices, and on ABR you'll specify stub summaries. You'll add the interfaces on OSPF, and you will configure also stub default metric of 30, which means that the routes which will be shared to area 1 will have a administrative distance of 30. And on R3 you just specify the interface. You specify that the area 1 is a stub area, the interface which is participating in OSPF. We can also have the total stub area. A totally stub area is the area that does not contain SBRs, and it is accepting only type 3 LSAs, which are sent as a default route, which means that R2 will not send any route learned from other areas, but instead it will send a default route. So all the traffic which will originate from R3, let's say, will have a default route that will point to R2, and after the packet will be delivered to R2, it will know what to do with the packet. Configure it the same way, but for the ABR router you configure stub no summaries, and you also add the default metric. And the configuration for the not so stubby area on R3 is also the same. We can also have not so stubby area, and in the not so stubby area we'll have the ASBR. Basically it is working the same as a stub area, but you have a router here which is connecting to the outside world. In the not so stubby area, the R2 will send the routes which it learned from other areas, and R3 will generate the external NSSA external LSA or the type 7 LSA. It will send to R2, and the R2 will transform this type 7 LSA into the type 5 LSAs. The configuration is also pretty simple. As in the stub area, you just specify not so stubby area summaries, you specify the default metric, and you specify for the router R3 that he is in a not so stubby area. Also we can have totally not so stubby area. It works exactly as a not so stubby area, but like in the case of totally stub area, the R2 will send a default route, and R3 will generate a type 7 LSA, which will transmit the external routes to R2, and the R2 will translate the type 7 LSA into type 5 LSA, and it will send those to the other routers. Configuration is also pretty simple. You just configure on the ABR NSSA no summaries, the default metric. On R3 you just specify that this area here is not so stubby area. The router roles, because this multi-area types is a very loved topic in the interviews, and some interviewers will definitely ask you the OSPF in case you are a beginner network engineer, and they will ask you OSPF if you have some experience. Depending on your level of experience, they might go deeper and deeper into OSPF. And also a topic that the interviewers like is to ask which LSA types are being exchanged in which areas. So I will give you some exercises to practice the type of LSA identification. The troubleshooting is pretty similar. The troubleshooting is pretty similar with the single area OSPF. If you don't have a neighbor detected, you should check the interfaces, the IP and subnet masks, the area number, the hello and the timer. And if neighbor relationship is stuck in the X-start, you should check the interface MTU. What can be different here? That you may not have the routes correctly exchanged in different area types. And one thing that you can check is the configuration. You should check if you configure the stub not so stubby area correctly. You should check that the ABR have the stub summaries or NSSA summaries, if it's a stub or a not so stubby area, or it should have stub no summaries or NSSA no summaries, if it is a totally stub area or totally not so stubby area. And internal routers should have the area type correctly defined, which can be stub or NSSAs, which means that the internal routers don't know if they are in the totally stub area or in the totally not so stub area. They just think that they are in the stub area or in not so stub area. You can also view the OSPF database by typing show OSPF database, and you can see the neighbors by typing show OSPF neighbors. We will play with the configuration in the upcoming lab. So thank you for sticking with me till the end of the OSPF. I will have more great things for us to play with in the lab. Thanks and goodbye.